Hello, this is Captain Chaudhari. In my last video, we discussed some basic terms like displacement, freshwater allowance, and TPC. Now, in this video, in this lecture, what I want to do with you is some practical, very simple calculations like which are dependent on the change of density. Change of density from freshwater to saltwater, from saltwater to dock water, etc. Right? So let us do a few simple examples. Let us say there is a ship of displacement 24,000 tons and TPC 25. So let us say the ship is here in a dock. And let us say this is open waters and this is summer zone. And if we look at the load lines, here is the load line disk, right? And here is the summer load line. We are looking at the starboard side. This is winter, this is summer, this is tropical, and over here you will find freshwater, and then you have tropical freshwater. Now apparently the ship is in freshwater dock. Here it is freshwater dock, and probably she is presently floating at summer load line. How much she can submerge? As you know, in the dock you are allowed to submerge by a margin called dock water allowance. Like in freshwater dock, the amount of sinkage that will be allowed beyond the summer load line is freshwater allowance. So probably from this point to this point, what you have is a freshwater allowance. That is what is asked, how much you are allowed to submerge. So as simple as that, you are allowed to submerge by an amount equal to freshwater allowance, because that is the amount the vessel will rise when the vessel goes from freshwater to saltwater. So what is the freshwater allowance equal to? Freshwater allowance equal to displacement upon 4 TPC in freshwater allowance in millimeters is equal to 24,000 tons divided by 4 into 25. 4 into 25 is 100, so it is 240 millimeters. That is the freshwater allowance. Now this kind of sinkage would be permitted. But now if I want to load the vessel in freshwater, I need to apply freshwater TPC, because normally the TPC that is given for the ship is saltwater TPC. So how to find out the freshwater TPC? Freshwater TPC is the normal saltwater TPC, that is 25 into 1.000, that is the freshwater density divided by 1.025. So that will give me 25 divided by 1.025. That gives me 24.390. 24.390. So that means the ship can load 240 millimeter is 24 centimeters. So the ship, to submerge from here to this point, she will be loading 24 multiplied by 24.39, that's equal to 585.4 tons approximately. So what happens is, if the ship loads while she is initially floating at this draft, and we know that since she is floating at a freshwater dock, she is allowed to submerge herself by an amount equal to freshwater allowance. That means she is allowed to submerge 24 centimeter, and in freshwater, to submerge 24 centimeters, I have to find out what is the freshwater TPC. That was 24.39. 24.39 multiplied by 24 gives me 585.4 tons she can load. And when she loads like this, probably she will come to this mark, and when she goes to saltwater area, that means open sea, 1025 density, she will come back to summer load line. Let us do one more question to understand the application of dock water allowance and how to find out dock water allowance from the freshwater allowance, and also how much you have to load in dock water so that when you go to summer zone, when you go to salt water, you are appropriate for the load line mark. So let's consider a question like summer displacement, let's say 22,000 tons. Let's say TPC is equal to 24, and we just saw the load line marks, and say this is summer, this is winters, and this is tropical. Now, present water line is about 15 centimeters below the summer load line. That means the vessel is not even submerged the summer load line. She is 15 centimeters below, 0.15 meters. And now she needs to load in this density. Density of dock water, say, is 1.008 tons per meter cube. Now in this density she has to load to a water level which will be probably somewhere here, this would be probably dock water level, right? So presently you have this water level, and then you want to load the vessel in this dock to this water level so that when the ship sails out, comes to the salt water, she is at summer load line. So how much sinkage is permitted right now? The sinkage permitted right now is, first of all, this sinkage 0.15 meters, and also additionally this distance, which is dock water allowance. So presently the vessel can be submerged by 0.15 plus dock water allowance. Now how to find out dock water allowance? Dock water allowance upon freshwater allowance is equal to salt water density minus dock water density, salt water density minus freshwater density. So if we consider the density as kilogram per meter cube, we can say the denominator is 25, that is 1025 minus 1000, and the numerator would be 1025 minus 1008, that is 17. So we are given nothing. We are not given freshwater allowance. So freshwater allowance would be, the freshwater allowance is displacement upon 4 TPC, 229.17 millimeters. And therefore the dock water allowance will be this figure multiplied by 17 equals divided by 25. That gives me 155.83. So dock water allowance is equal to 155.83. So therefore this is equal to 0.156 meters. So you are allowed to submerge the vessel by 0.15 plus 0.156, right? So the total submersion that is allowed is 0.15 plus 0.156, that is 0.306. Submersion allowed is 0.306, right? Now what is your TPC? TPC 24, when nothing is stated what is the density, you have to assume that the TPC is given for salt water. So what is the TPC dock water? Dock water TPC is equal to salt water TPC, that is 24, multiplied by dock water density 1.008 divided by salt water density 1.025. We can say 1008 divided by 1025. So that gives me 24 into 1008 equals divided by 1025. That is 23.6. 23.6 is the dock water TPC. So we are allowed a submersion of 0.306, that is 30.6 centimeters, and dock water TPC is 23.6. So 23.6 multiplied by 30.6 gives me 722 tons. That means if the ship loads 722 tons, right, then she would come, presently her water level is, presently her draft is over here. When she loads 722 tons, she comes something like over here, and from here when she sails out and she enters summer zone, that is salt water, water level would automatically come to S, that is the summer draft mark. Now let us do a question where change of density with the tide is involved. This is the tidal port, tidal variation, tidal range is 3 meters. The ship is in near full load condition, in the density 1.020. That is the density when the vessel is at high tide. At low tide, the density is likely to reduce to 1.008. There is a tidal variation of 3 meters. The range of tide is 3 meters. Initially, there is under keel clearance of 4 meters. Now, you are expected to find out what will be the under keel clearance when the tide changes along with the density, and also the tidal height changes. So, let's put down the data. The vessel is nearly full load. The density 1, that is the high water, density 1 is 1.020, and at low water the density is 1.008 tons per meter cube. Now in this change of density, what's actually happening is as if the ship is going from one density to other density, higher density to lower density, which means the ship will sink. And it seems from high water to low water, the range of tide is 3 meters. So initial under keel clearance was 4 meters. You are expected to find out what is the new under keel clearance. So the freshwater allowance given in the question is 218 millimeters. So the first thing we need to find out is what is the change of draft because of change of density. Now this is not the complete change of density from salt water to freshwater, so we are not applying the freshwater allowance, and the ship is not going from dock water density to salt water density, so we are not applying dock water allowance also. What we need to find out is change. First of all, we must understand that change of draft is proportional to change of density. This is the principle we are going to use. So change of draft, when the vessel goes from 1.020 to 1.008, divide by change of draft when the ship goes from 1025 to 1000. That means the change of draft divided by freshwater allowance should be equal to, what is the change of density from here to here? It is 12. And what is the change of density from salt water to freshwater? It is 25. So we know the freshwater allowance as 218, so we can find out what is the change of draft. So change of draft when the ship goes from this density to this density would be 12 into freshwater allowance 218 equals divided by 25. That means 0.105 meters. 0.105 meters. This is the change of draft when the ship goes from this density to this density. Actually, the ship is not going anywhere. Ship is there only. Now, this problem can be understood in two parts. Part 1, where the density changes from 1.020 to 1.008. And in this phase, in this part, the vessel sinks. The vessel sinks by 0.105 meters. That means under keel clearance should reduce by 0.105 meters. And the question can be understood in second part, whereby the tide is changing. Tide is changing from high water to low water. That means there is a reduction of UKC by 3 meters. So there is a total reduction of under keel clearance by 3.105 meters. So new under keel clearance will be 4 meters, which was the initial under keel clearance, minus 3.105. .895 would be the under keel clearance. Now a further question could be asked, like if master wants to ensure UKC of 1 meter, then how much cargo should be discharged? Now we have understood that the UKC is reducing because of the change of tide and because of change of density, right? So from 4 meters it is getting reduced to 0.895 meters. But if we cancel the effect of change of density, that means if we discharge the cargo so that there is a rise of 0.105 meters, then the vessel will still have a UKC of 1 meter. So let us find out dock water TPC for 1.008. So dock water TPC is equal to normal TPC, that is 25 into 1.008 divided by 1.025. That is equal to 25. That is 24.58. So the amount of cargo to be discharged should be equal to 10.5 into 24.58. 24.58 into 10.5 gives me 258.1 tons. So in this situation, if we discharge 258.1 tons from the ship, then we will still have an under keel clearance of 1 meter at low water.